Same session of 2018-2019, but we're continuing on from number 28. For the previous numbers, the numbers I skipped, the questions I skipped are basically revolving around solubility and complexes. Now I know that for this current year, solubility and complexes are basically cancelled, but I will be putting the answers for those questions after I finish the redux part. So for the redux part, in number 28, it says that the following redux reaction occurs spontaneously. That's good. You have the redux reaction written right here. You can separate the reaction into half reactions. Of course, you should know how, but don't waste your time in an exam until you actually find what it is that they want. So the balanced half reaction that would happen at the anode, what happens at the anode is basically the oxidation half reaction is. So what is oxidation? You already know that oxidation is basically loss of electrons. Look at your reaction and note which element loses electrons. Calcium was a solid. It loses 2 electrons to become positively charged, which is calcium 2 plus. Very easily, this is the one that loses electrons. So calcium loses electrons to become Ca2 plus. How many electrons? Remember that the reaction has to be balanced in terms of elements, atoms, charges, all around. So that is your correct answer. It's calciumetry, calcium 2 plus 2 electrons. Number 29. Balance the following redox reaction. It's quite easy to do so. Start with, let's put this right there. Start with the series that you're most familiar with. So I know that you study MnO4 minus a lot. Okay, so MnO4 minus in an oxidation reaction will yield Mn2 plus. Remember, this is something that you have seen several times in your course. Several times. So all you have to do is start by balancing your atoms. So you have 4 oxygens on the left hand side, add 4 H2O molecules on the right hand side, then balance your hydrogens with either acids or bases. If you look, we have an acid, so that's 8 H plus, and then you can balance your electrons. Remember, you can balance your electrons whether at the beginning of a reaction or the beginning of your balancing or the end. It doesn't really matter. The number of electrons will always stay the same. So Mn is a 7 and it changes into a 2, so that means it gains 5 electrons. Now we need the remaining species, which is SH2SE selenium O3. Remember, what is a reactant stays a reactant. What is a product stays as a product. And the only difference here between the reactant and product is basically the oxidation number of selenium, because you start with 3 oxygens and you end with 4 oxygens. First step, balance the number of oxygens. So you have an extra oxygen on the right hand side, add an H2O on the left hand side, then add 2H plus on the right hand side, and then calculate the oxidation numbers of selenium. In both cases, you will see that the difference between both is basically 2 electrons. I'm assuming that you know how to calculate the oxidation number. To elaborate, so basically the oxidation number here is 2, which belongs to, let's say, plus 2, which belongs to hydrogen in this case, X for selenium, 3 into minus 2, and the total charge is basically 0. This is something that you already know, so it's basic arithmetic. So x is basically minus 6 plus 2. That's minus 4, so that's plus 4. This is something that you should know. Same way, so it's basically 4 into minus 2. So that's minus 8 plus 2. It's minus 6. So it is plus 6. The difference is 2. And it's loss of electrons. What you have now is 5 electrons gained, 2 electrons lost. This is a discrepancy. What you do is you change 5 and 2 into a common factor, which is basically 10. 10, it means that you have to multiply this by 2, the entire series. So that's 2 times 8, and 2 times 1, 2 times, let's just put these, 2 times 4, 8, again 2, 16. You multiply by 5. So that is also 10, multiply 10, 5, 5, 5. What you do now is you start to subtract the commonalities. What do I mean by that? Basically, you have 16H plus, 10H plus. What you have left is 6H plus. So you have 6H plus in your reactant. You have 2 MnO4 minus, and you have 5. So the first series is basically 5 to 6. That's it, 5 to 6. You can, of course, verify. If you move on, you have 5H2O, 8H2O. What you have left is 3H2O. On the right-hand side, 2 Mn2 plus and 5H2SeO4. So it's 5 to 3. Take note that when I'm actually writing the series, I'm matching it with what I have here. So it's 5H2SeO3, 2 MnO4 minus, 6H plus, etc. Okay, number 30. Consider the following redox couple, which is basically ClO4 minus, ClO3 minus, and I quickly noticed that I have a common species between 2 of them. That means one of them, this particular species, if a reaction occurs, it means it's an amphoteric species because it can play the role of a reductant and an oxidant at the same time in a reaction. What you can do before you basically start to look at everything is that you can assemble it on the E0 scale. Remember, the E0 scale actually tells you the same as acid base. It tells you which one is the stronger reductant, which one is the stronger oxidant. Reaction is or always happens between the stronger reductant and the stronger oxidant according to the gamma rule. It can happen in the opposite direction, but the severity of the reaction is different. So what you do is just assemble. So that's 0.35 ClO3 minus ClO2 minus 0.17. You don't have to do this. I'm just showing you how it's done. So ClO4 minus, it's how we write the couple. ClO3 minus. If you look, I have no idea what's happening. If you look, ClO3 minus and ClO3 minus can react together according to the gamma rule to give you ClO4 minus and ClO2 minus. Pay attention that if you go back to rules, the rule of spontaneity, even from thermodynamics, but in electrochemistry, the rule of spontaneity is that delta G, first of all, they do have to specify whether you are at standard conditions or not. Okay? The rule of spontaneity is for delta G to be negative. So whenever you have a reaction that is along gamma, and delta G, as you know, is proportional basically to delta E0, which is E cathode minus E anode. So if E cathode minus E anode is positive, delta G will be negative. This is spontaneous. Remember that. It's a very simple way to determine spontaneity without having to go into calculations. So which of the following statements are not correct? The amphoteric species, which is ClO3 minus, is stable, unreactive. This is not correct. Very simple. It's not correct. Why? Because it abides, the reaction between ClO3 minus and ClO3 minus abides by the gamma rule, which is the first rule for spontaneity. If it abides by the gamma rule, it means that delta G will eventually be calculated as to be negative. So that is true. Now you can put this answer and move on, but you have to pay attention, or you have to pay attention to the fact that you do have an option that says E and D. So we can forget about B and C, trying to determine if they're right, and strictly move to D. D says that the reaction between ClO3 minus and ClO3 minus, which is along the gamma rule, is spontaneous. This is true. But they want what is not correct. So the answer is strictly A. It's not A and D. 31. The oxidation of hydrogen by oxygen is one of the most used reactions in fuel cell technology. The overall reaction is written as follows. Pay attention that they do give you what delta G0 is. What is the standard potential of this cell? Pay attention also to the word standard. There is a very simple rule that combines delta G0 of this cell, because this is given for a cell that contains both the oxidation and reduction reactions. So delta G0 is equal to negative the number of mole of electrons exchanged times Faraday's constant times E0 of the cell. A lot of people put delta E0, it's the same thing. When I say E0 of the cell, I do mean E0 cathode minus E0 anode. Good. So delta G0 is basically equal to N. What is N? Go back to your reaction. Try to take only one of these half cells and separate them. When you have H2 plus O2 to give you H2, it means H2 is actually a product of both the oxidation and the reduction reaction. All you have to do is one. That's it. Okay? Either O2 or H2. So if I take O2 and I have to change that into H2O, the oxidation of O2, remember here, is 0 because it's an element. Same rules apply. I have 2 oxygens, multiply this by 2. Now I have 4 hydrogens, add 4 H plus to balance. And now all we have to do is balance out the electrons. So 0 minus 2. However, I have 2 H2O molecules. Every oxygen is minus 2, so that's minus 4. It means that this oxygen has gained 4 electrons. And this is the balanced one. Pay attention to whatever is not balanced. So this is 4. We now have 4. Faraday's constant, E0 of the cell. What's delta G0? Yeah, minus 4 is 7. 4. Remember, you have to match basically the units. So this is in joules. E0 of the cell is 1.2279 volts, and that is approximately equal to 1.23 volts.